I'm Mrs. Lang, Savannah's mom. Some of you know Savannah, and I've popped in Mrs. Edwards' class a few times. So I'm going to go over, we're going to look at a sleep deprivation problem. Teens and sleep. Sleep is important. We know you all aren't getting enough. So take a minute, read the article, and that's just very short, and then at the bottom, write down how many hours of sleep you got last night. Pause. Okay, we're back. All right, so how many hours did you sleep last night, Mrs. Edwards?
6.
6 hours. Okay, did you look on your Fitbit? Is that accurate?
Yes, it is.
Okay, very good. Okay, so hopefully when you paused, you discussed a little bit about sleep. If you would like to do that now, you can. You can take a couple minutes and talk about how important sleep is for us. And then unpause. Okay, all right, so let's look at this. So sleep, the amount of sleep we need, especially at different stages of your life, and Mrs. Edwards and I both have the same philosophy about you're a baby and babies sleep a lot, right? And then you grow up and you are at the apex of not needing too much sleep. And then as you get older, did you know 40-year-olds need a nap again? So we actually need more sleep, so be nice to us old people.
I wish I was 40, but thank you.
Yes. but so you need more sleep than me.
I do.
You need
I need a nap.
Okay. All right, that is statistically true. Okay, so in this, what we just read, there's a survey administered to high school students showed that the amount of sleep that they get on a 24-hour period is normally distributed with about a mean of 7 hours. So most teens need about 7 hours. So we're going to put this in the middle because remember the mean was the most often number, the mode, and it was the median, meaning the middle. And I know Miss Edward mentioned that according to the empirical rule, this is if you surveyed all teens and all sleep, some got more, some got less. There's 50% that got above the mean and 50% that got below the mean because that's 100% of the students. Okay, so then we always want to compare, are you below the average or are you above the average? So let's go ahead and pause your group and you can talk about, just to take a minute, and how long did the longest person last night sleep in your group? Pause. Okay, unpause. And we're just going to, I'm going to use Mrs. Edwards up here, but hopefully you had a good conversation of y'all's sleep last night. So we'll say 6 hours. Okay, so the next question is, now we want to know what percentage of high school students from the survey slept less than this person. Okay, and if you remember from Savannah's growth chart with her head and then the normal distribution, when we compare things in a normal distribution, we're always comparing with one standard deviation, or which is the first percentile, second percentile, and the third percentile. So we always kind of want to look at those distances. So there's the first one from the mean. That's about 68% of the data falls within there. And then we have about 95% falls within here. And then we have about 99% falls within here. And then we have a little half and a little half. Okay, so what is the standard distance between these? So there's a standard deviation of about 1.25. So if someone slept exactly right here, they were exactly on this quartile line, this percentile line, and the first percentile, 1% above the mean, what would this be?
8.25.
Very good, 8.25. Okay, so what would this one be below? If this is above 8.5, this would be
575.
5.75. Okay, so now this is 1.25. Now we go another 1.25, another distance to the mean. So how much is this one?
9.5.
9.5. And now there's 1.25. We need to go another, we just subtract again.
4.5.
4.5. Whoops, that's a 4. And then let's go one more above. So 9.5.
10.75.
So 10.75. And then 1.25, 1.25. So this is 1.25.
8.25.
8.25. Okay, so if you have to set up your distribution chart, really all of these on this whole page should be set up this way because it's the same data that we're looking at. But now we're going to compare a different person each time. So this is 6. I'll just write a different color. All right, so is this person above or below the mean?
Below.
Okay, very good. All right, so where are they going to fall? They are not in this first percentile. Wait, they are. They're right here in the first percentile here. They're right here. All right, and we're comparing what percent of high school students slept less than this person. And we write it like this. We say what percent, so X is the number of students, or the percent of students that slept less than this person. Less than that person. So this would be everyone that slept more than that person, and this would be everyone that slept less than that person. So we're going to shade right here. Okay. So what was important to know about this person? What's the first thing we need to look at to figure out what is this percentage? We need to look at how far they are from, we're always comparing everything. How far are you from the mean? How far are you from the average? So what's the first thing we're going to do? How do you figure out distance on a number line? Because really this is just a number line. How do we know how far it is from here to here? Good. We subtract. So we're going to go 6 minus 7. So that's the distance to the mean. And then we're going to divide that. We're going to standardize that. Divided by 1.25. Which is, I'm going to be lazy, which is negative 0.8. It's a negative number.
Is it 0.80?
It's just 0.8.
Okay.
Just 0.8. So why is it negative? That's negative because it's below the mean. Okay, so we know we are negative 0.8 standard deviations. One standard deviation is 1.25. We are 80% of one full standard deviation. One full standard deviation is here. We're 80% of one standard deviation below. Whenever it's negative, you know you're on this side. Whenever it's positive, you're on this side. Okay, so what am I going to do with that information? I'm going to look at our table. Okay, so you've got a z-score table. Grab your z-score table, and you'll notice you have a positive z-score table, and you have a negative z-score table. But what do they have in common? Look at your two tables. Just look at the pictures. You don't have to look at anything else. What do the two pictures have in common?
The shade is on the left.
Shade is on the left. They're both shaded below. So if you're using this side and I need this information, remember we said the whole thing was 100% or one whole. You're going to have to, if I know this amount, let's just pretend this is 80%. I'm going to have to subtract from 1, then I'm going to have to know that that's 20%. Oops. And then for this one, if I know that this is 15% and I really want this information, I'm going to have to subtract from 1 and know that that's 85%. Okay, so where were we? Were we above or below? We were below. So we're going to look up on this one, on our negative z-scores. Find your negative z-scores. We were negative 0.8. And it was not 0.8 with anything after the decimal. To read your table up here, this would be if it was like just negative 0.8. This is negative 0.81. This is negative 0.82. So we always round to the hundredths place. Okay, so we are at negative 0.8. So look at this number here. What in the world is that number? What in the world? 0.2199.
2119,
Sorry,
wasn't it?
2119. Okay, so we have 0.2119. What does that mean? Okay, we can look at this as a probability, which means out of 1, or we can look at it as a percentage, which is always out of 100. If you notice, all the numbers on the z-score table are less than 1, because 1 would mean the whole thing is shaded. That means every single person slept the exact same number of hours. There is nothing to compare. Okay, so this is telling me that everything to the left of this number is 0.2119. So out of, if we want a probability, that's the probability, because it's out of 1. If I want a percentage, then that's going to be 21.19%.